Hello, welcome. I'm Randy Jones, and thank you for joining us for unit testing with the JavaScript API. Jackie Roberts will be joining me, and we are developers with Esri's Professional Services Division. We help clients build custom applications or custom widgets, or design their enterprise architecture. Sometimes we help organizations with just starting a project, or we see them through all the way going to production. So we've given a talk similar to this for a number of years now. And so last year what we did was we had a lot of demos, we talked about tons of different tools, and we're going to do similar this year. But the way that this is going to flow is we're going to talk about some testing basics, we're going to talk about test-driven development, then Jackie's going to lead us through testing with a lot of different frameworks. And then we'll come back and talk about adding testing to legacy applications and testing within Web App Builder. So let's dive right in. So normally, as developers, we end up writing test cases similar to this. We write our code and then we write tests. Then we write more code and that ends up breaking our tests. So we rewrite the test. This is not an ideal testing scenario. We don't want to be rewriting our tests to fit our code. We want to be writing code to fit our tests. This is where test-driven development comes in. The idea of test-driven development is for us to first write our tests, and the test will immediately fail. Once the test has failed, we begin to write code until our test passes. Then we start this process of refactoring our code and adding elements to our tests to achieve the goals of our development. Now, while this is an ideal case, I think it's best to understand that testing and adding tests to our code is the number one goal here. So if you don't 100% adhere to best practices for test-driven development, that's okay. What we want to try to avoid is falling into the trap of 100% of the time writing code and then writing our tests. Even myself as a developer, I often don't 100% adhere to these test-driven development practices because honestly, sometimes it's difficult to do. But instead of throwing away all aspects of testing, give yourself some grace and just do the best that you can in following this format. So when we're talking about testing, we really have three rules that we want to emphasize. Rule 1 is don't test other people's code. Whenever we're building tests, we want to remember to test our parts and not the bits that other people are already testing. Frameworks like the JavaScript API or Dojo or jQuery or React or Ember or Angular, all of those projects are already testing their code. So when we think about this in the context of a JavaScript API app, we don't need to test that the map ended up panning to where it needs to be. We don't need to test that a layer loaded and fetched tiles. What we want to test is our part of the code. Maybe we take in a set of coordinates and we perform a calculation. Well, we want to test that we got the proper output of that calculation. Not that then when we add that to the map, that it displays properly. We might want to test that when we properly call adding it to the map. But we're going to avoid testing things related to the map, related to layer loading within our application. So again, to emphasize, remember to test your custom parts of the code and widgets, and remember not to test what frameworks and APIs are already testing. Rule 2 for us is to prioritize. Part of the important thing about this is we want to be using testing to optimize our output. We want to be using tests to lessen the overall load on our QA to deliver code faster and better code. And what that means is that we can't test everything. It's unrealistic for us to have 100% code coverage. That's always a lofty and good goal, but it's generally unreasonable. So think about the aspects of your business logic within your application and make sure you're prioritizing the most important things within there to write tests for. Whenever we think about testing, we have this test pyramid. And at the very top, we have functional testing. Functional testing is very expensive and requires a lot more tooling. You're testing a lot of things and there's lots of dependencies within your tests. So one small change at anywhere within your stack could break a functional test and require reworking it. On the flip side, unit tests are very easy and very cheap. Developers are developing these tests to look at very small bits of their code at a time. This leads us to better develop our code and encapsulate it just into small bits. Because unit tests are meant to have almost no dependencies, they end up being very easy to write and very easy to maintain, and they should be the bread and butter of any good testing suite. If we think about things another way, we can think about where bugs are and how bad they are to fix when changes happen. If we're thinking about our test pyramid and have lots of functional testing, fixing bugs becomes very difficult because when a test breaks, is it because a button moved and there's really nothing wrong with the underlying logic? Or is it because some dependency is missing? So thinking about unit testing, we get things down to much smaller, and as a result, the nightmare is a lot less for us. Developers are really good at writing code that's very hard to test, but it doesn't have to be that way. So what you want to do is encapsulate, encapsulate, encapsulate. We're looking to create these small bits of code that will be the interface between the application and your custom code. These small bits are easier to test, and as a result, they're also easier for us to maintain. This means that as we're developing, we need to be careful about including inline functions for click event or asynchronous callbacks. Breaking those out into a full separate function allows us to test those bits of code. So next time you're thinking about writing a big, large test of code block, think about refactoring that to have better encapsulation so that each bit is testable within your testing framework. So Jackie is going to talk to us about testing from the very start. Jackie?
All right. Thank you, Randy, for the introduction and laying groundwork on Principles 1. unit testing and test-driven development. So testing from the start. I'm Jackie Roberts. I'm a front-end software developer in professional services within Esri. Hooray! I'm going to spend some time talking about the opportunity we have when we get to start an application from scratch. In my experience, this is more rare than working on a legacy application where you get what you get, inherited wonkiness and all. So with a brand new application, it's typically one of the easiest ways to start with true test-driven development. It's like a brand new baby application you get to raise in all the right ways. So when this opportunity does happen, I would like to take the next couple of minutes to demo what it takes to use a CLI, edit some boilerplate that comes with creating that app, and get unit testing set up so you're ready to go. This is really driven by feedback from last year to help with your ability to walk away from this talk and get started incorporating unit tests on your own. Can I React, or Angular, or Ember, or new trendy framework? Yes. So with CLIs, many different testing frameworks come built in, or take very little effort to get set up and configured with just a tiny bit of reading the manual or some Google foo. So today, I'll dive deep on a specific one, working through the cycle of test-driven development in an app built with the Create React app, command line interface, and incorporating in Esri Loader. So we'll take advantage of Create React App's built-in Jest testing framework, and also I'll include Enzyme, but I'll get into that in just a little bit. So, getting started. The first thing we're going to do is I've npm installed Create React App, and I'm going to run Create React App and then create my application build Esri Loader. So once that's set up, I'll change directories into my new application, and you can see what's there. I'll open up VS Code in just a second. We'll take a look with what's coming there out of the box. And then right away, I'm going to go ahead and npm install my Esri Loader as well. And you have some links at the bottom for reference. All right. Let me switch to VS Code. All right. So again, based on feedback from last year, I'm just going to spend more time explaining some of the context and basics to get you set up with testing using this specific framework. And then I'll focus on the steps you'll take to get unit tests incorporated right off the bat with a new app and walk through the back and forth cycle of test-driven development. So I'm going to just, as I do this, show you right here, build Esri Loader. I'm in my application. Right at the bat, we have build, node modules, we have public being where you might want to go ahead and change your favicon or your index.html. That'll have some boilerplate in there that references a React app and has a React logo. So I went ahead and just included my own icon and labeled it sample Esri Loader build. Aside from public, you have your source. Typically what comes with this application when you run the CLI is you get your app.js, a test file, and a CSS file. You have your index.js and the CSS file for that. And then you have down here your service worker and your setup test.js. We'll take a little bit more of an in-depth look at setup test.js in just a moment. And so index.js, this really is your entry point to your application. And then it's referencing and pulling in everything from your main app right there. So one thing I went ahead and did was added a components folder, so React very component driven, and that's where we'll add in my webmap view component later on. So there's a lot of component testing techniques. They range from a smoke test to make sure a component renders without throwing, to shallow rendering and testing some of the output, to full rendering and testing component lifecycle and state changes. So the first thing I want to take a look at is setup test.js. Right in here, you're getting just out of the box, the testing library for Jest, which comes wrapped up and bundled with your Create React app. That's its set. So Jest is its test runner. We don't need to install Jest, but do keep in mind that Jest runs in Node and is focused on unit testing. So if you're looking for like browser end-to-end testing tool, you'll need to incorporate something else for that. Jest automatically looks for test files with naming conventions such as star.js. So anything that ends in star.js. If it were located in a test folder like that, or anything under source labeled .test.js or .spec.js suffix. So you can see right here, app.test.js adheres to that convention, so the test runner will know to look for that. So right now I'm going to go ahead and change it to as we load it. It's already installed in a different tab. I have it running, but I'm going to go ahead and run npm test. So as that's booting up, it's going to be running in watch mode. So every time you save a file, the tests are rerun. You can choose to run all the tests or just a specific file or pattern. Jest does run tests on files changed since the last commit for efficiency's sake. So you can force the override by pressing A in watch mode right here if you really wanted to. You can see everything right here is untracked. So it's going to be running all of my tests as I go through. So right now it has 1 pass, 1 total. So really what that is the out-of-the-box test that we're going to see with app.js and app.test.js. So what this looks like is it's just imported React, it's imported its component app, and this is a simple test to see, does this app render without crashing? Right there. I am going to, when we create our component, use shallow from Enzyme versus this react-dom.render. So Enzyme is a JavaScript testing utility for React that makes it easy to test React components. And specifically, shallow allows for an isolated test of the component. So if there's child components contained within what I'm trying to test and they throw an error, it won't break the test for the specific isolated component that I'm focusing on. So in order to do so, I'm going to install save Enzyme React add-ons test utils. So as that's going through, I'm going to go back up to setup test.js. And within here, I need to go ahead and configure an adapter to work with Enzyme. So I'll go ahead and import configure from Enzyme. And then I'll go ahead and import adapter from Enzyme adapter React 16. And then down below, configure adapter. Just that. All right. So now if I'm referencing anything with Enzyme, I have that adapter configured and that'll work. Okay. So test-driven development, the first thing I want to do is write my test. If I take a look at app.js right now, it's running. It's just a simple app with a div, class name app, sample starter app. Okay, what I want to do is I want to throw a web map view in there. So if I take a look real quick, I have my sample starter app. That's it for now. All right. So then the first thing I want to do is I want to create a test file for the component that I'm going to create. So if I go to components, I'm going to do a new file, and I'm going to label it webmapview test.js. So when I go in here, the first test that I'm going to have is really just that I'm going to use that shallow smoke screen test to make sure it renders. I want my webmapview component to render. So test. Something descriptive for whatever this test is supposed to be doing. So just rendering webmapview without crashing. and then shallow web map view. Here. So right now you can see this test is failing. It should fail. Your tests, you write them, they fail, you write the code, it passes, right? And you go to refactoring. So we have it right there. I have my test in there. Now what I want to do is it went ahead and auto-imported some stuff for me, the shallow. I'm going to also need to import the component that I'm going to make and test out. So right now, web map view. I have it in the same folder. That's another thing for your tests. I often fall into the pattern of having them be in the same folder as wherever my component is. Some people prefer to have a separate test folder, and then it's just about relative pathing how you import them and reference them. So it's really up to you. All right, so we have that in there. It is still failing because we have not written it. So let's go to app.js, and eventually we're going to have this be web app view. We're going to go ahead and import that in there. And right now, everything's going to fail because that React on the testing for app, it's using render, not shallow. So because it has a child component, the web map view component, it's also going to fail. So all right, now it is time we have our tests. We need to go ahead and create the component. So I have right here, web map view, just kind of stubbed out something pretty generic. I'm using the class style of React. So for our constructor, I need to just go ahead, super props, and then create a map reference for my I'm creating. All right. So I've done that. I want to go ahead and in here import my load modules from Esri. And then once the component did mount, I'm going to go ahead and lazy load the required ArcGIS API for JavaScript modules and CSS. So I have a couple things in here. I think for time's sake, I'm just going to go ahead and copy paste this in, and then I'll talk through it. So load modules. Right in here. Okay. So I'm calling load modules, and right now I'm just trying to get my web map view. So right here, map view, I insert that in. And then for CSS, you have a couple options that you can put in here. I'm just choosing to use the dark theme, but you can refer to the documentation for Esri Loader to see what your default or configuration options are there. So once I've done that, I'm creating my map. I'm going to set it to the dark gray base map. And for the view, I'm putting it on the container that I set up above in the constructor, and then just setting some basic options on it to show over DC. So I have that, and let me save it. And then afterwards, I'm going to go ahead and go to the unmount function. Still not passing just yet. Component will unmount. So if view, we'll go ahead and just destroy the map once it's done. So this equals. All right. And then last but not least, we need to render our component. So within here, I'm going to do class name equals web map, and then ref equals this map. All right. So in here, waiting for my tests to load. Test run is running. And oh, I have it failing right here in Web Map view. And okay, I'm just taking a look. Reference error, React is not defined. Oh, okay, so yeah, I need to actually incorporate that. So I'm just going to steal it from over here. React. Go ahead and put it at the top. And then down below, let my test suite rerun. And they both passed. Easy peasy. All right, so now that that's happening, I'm going to go back and take a look at my app. And here we go. We have a map over the DC area. Again, this was something that was fairly basic, just kind of going over that cycle of configuring tests, getting my library set up, writing the test, having it fail, writing the code, and then having it work. So there you go. Okay, let's return to the PowerPoint. All right. So just want to describe a couple more pieces of information here for you. So when you are using the Just framework, you can group related tests by wrapping them in describe, or you can just individually write out your tests with it or test blocks. Enzyme typically uses assertions based on similar chai, but with Just, expect is a global function for making assertions, so you can just use that right out of the box. There's an entire API of options within the Just.js docs linked below. And then just.function and expect function to be called are a great way to create spies and mock functions. So this is just like the basic intro of really getting it set up into your application from the get-go. I'm going to turn it over to Randy, and he's going to jump into really showing you some more some more testing with a legacy application and getting into some like deeper tests that you might be running when you're writing or creating your web mapping applications. Thanks.
Thanks, Jackie. Now let's look at a legacy application we've had for some time. Over the years, I've been using this enterprise build sample as an application to showcase a number of things. We have it showing a Webpack build, for instance, and an application that is the JavaScript API 4.7 or later. There's actually a branch that shows how to do the older Dojo build style with a project that is of a previous version than that 4.7. So let's look at what this project has for us. So if we look here in GitHub, we can see our project is laid out such that we have a web folder that has our custom application in it. Our custom application is pretty simple. It's got an index page and a JavaScript entry point and the classes that we have. So the application looks like this when it's running. We have a toolbar over here. That's what we call this class, where we can hide and show a couple of different layers. We can run a travel ring for geoprocessing and clear those graphics that are added to the map. Now this project is currently using Karma as a test runner. So Jackie has shown us a number of other options. This project using Karma. This is a nice test runner, very easy to work with, easy to debug, very nice framework. We're also using in this project Jasmine to perform our tests. I like Jasmine as a language over some of the other options. It's not to say that it's better or worse. I do like the format in which the tests go in. We have a test suite, and that describes something, and we expect it to be a certain way. So we'll look at that as we dig into our project. So how do we include those things into our project? You can see here we're going to use a number of things, and you can see in this project, because we have grunt and things to deploy our application and build the application. You can see a lot of the Webpack and grunt and those things. Here in the middle of our dependencies is where we see the ones that are really related to most of the testing. We see including Karma, the Chrome launcher for that, so we can view and see the test can run. Since the project is using Dojo, we include that. And the Jasmine plugins with Karma. We can see up here, since we're using Grunt as a task runner, we have the Karma plugin for that as well. So this is all in our package.json for our project. We've done npm installs, in this case with the save dev option. So Karma has its own config because we have to tell Karma where our tests are, where they should be running. Within Karma land, they put all the tests within a folder called spec, S-P-E-C. So in this Karma config file, you can see that we're telling it that we're going to use the Jasmine and Dojo frameworks. We're telling it the list of files to pull in. So whenever we look for this, we are saying, here's where the main file is for our tests. Here's where our JavaScript files are, and here's where all of our tests are. And because we're doing a star there within there, it's going to pull in all the tests. So as we continue to add more test files, we don't have to make any changes to the Karma configuration, which is nice. So if we jump over into our project, we can see here that I have run my project in a development mode. So if we look at the package.json, I'm currently running the start. So npm run start. We can see here what happens is, in parallel, we both do the serve dev command and the test watch command. So what this does is it runs our Webpack build and serves it out. And it runs our tests while it is starting. And then we look for any changes to our tests or to our JavaScript files, which will cause things to rerun both the tests and rebuild the Webpack build. So we have this running right now. And let's examine what a problem, a bug report, would look like and how we're going to modify this. So right now in our application, it's been reported that they believe as you zoom out, the hide assets button is able to be toggled at a smaller scale than it should be. So while we're not sure whether this is accurate or not, we're going to go look at the requirements and see if we can figure out what's going on in the code. So if we jump into our code, our toolbar class is where this is happening. We can see here in the post create of our toolbar class, we have an asset state button, inline function, and we can see that we are getting the zoom and setting an initial state of it, and then we're watching the views zoom, and updating the asset button state from there. Now we can look over here in our spec class, this is from the spec folder, that goes and contains all the tests for our toolbar class. We can see here what I'm describing about what I like about Karma here is we describe the components toolbar test, and we have some setup. Before each test, we need to create a toolbar, and after each one, we need to destroy it. And then what we're going to do is we're saying the toolbar, it clears graphics and info window as an example, right? So we're going to have that test there. We have one for toggling the street map. And you can see in this one, we're not actually testing whether the layer has been shown or not shown on the map. We're checking to make sure that our function that does that toggle has been called. So now we're getting to our test about the assets button. And we find that somebody did a good job of taking the requirements and putting in comments, stubbing out what the test should look like, but didn't actually implement the test. So in our test-driven development model here, what I'm going to do is go ahead and write my tests, fill these tests in. So I've cheated in so much as only getting the function name from the existing toolbar. I'm going to say toolbar, we're going to call this function, and when it's less than 10, we expect the toolbar assets button to get this disabled property, and we expect that to be truthy. Now similarly, we're going to also test for when it's greater than 10. So we'll change this to 11, but at this point we expect it to no longer be truthy, but to be falsy. So now we have our test written. I'm going to save it, and as you can see, the watch kicked off, and we have our Karma unit test running. And we can see that it failed as we expected. We wrote our test to the specifications as were shown in the file, and we can see that the way that it fails is it says it's not even a function yet. So we can come back over here to toolbar, and let's begin to build this function out. Now, since I already have some code for this function, what I'm going to do is I'm just going to start refactoring this code. This is a great example of code that needs to be refactored so that it is testable. Because we have that inline function, we can't get to the functionality to test it. So we're going to go ahead and create this as a function. And then we'll go ahead and modify our call back up here. So we'll hitch those together because we're using this both to set the initial state and the state of our button when zoom changes. So we'll save this. Again, we'll see that a file has changed. We'll see that our file was first linted, and now it's going through Karma unit testing, and it fails again. We can see in this case that it wasn't able to find the function. If we properly scope the function and save again, we again see our linting happening, our unit test happening, and test should run, and yet again fail. But what we see now is that the test is failing because we have a problem over in our test. I've come over and fixed the spelling of the toggle assets button and saved that class again. Now, as the test runs, we can see the back and forth play that happens as we write tests and write our code together. Now we're seeing that our code is running correctly, except that we're getting an error from our test where we expected the toolbar to be false, but it ended up being truthy. If we come back over in our toolbar and examine our code again, we can see that if the zoom is less than or equal to 6, we have a problem. Our test showed us that this value should be less than or equal to 10. Now that we've updated that, we see that our test will run one more time and be successful. We can now come back over into our application, refresh it, and see now that the asset button, as we zoom back out, disables itself at a much larger scale than it did previously. Now that we've looked at an option for the web app builder, when we think about the web app builder, there's different considerations. Because the framework is very opinionated about how widgets look and how the project is laid out, the other problem and challenge that we have is the fact that web app builder has lots of dependencies between it. So we have a strategy to build widgets that allow you to incorporate testing easily and have it work well within the web app builder. You can use the web app builder build also to optimize your web app builder projects when you're done. A great way to start one of these widgets is by using the Yeoman Generator. The Yeoman Generator that you can find here at the GitHub, link below, gives you a way to start a widget. It scaffolds out everything, puts in testing, and steps you through configuring what web app builder application it should be copied to while you're coding, and will give you the ability to both test the widget and develop it as you go. Into that project, you could also put web app builder configuration, etc., so that you have your web app builder code separated from the core of web app builder. So now that we have a stubbed web app builder widget created, let's look at what it looks like to have one of these widgets. Here's a project. We can see that it's been created by the Yeoman Generator by noticing this .yorc JSON file. We can see that a widget folder was created, and we have a single one with a widget called Go to Dev Summit. We also have the spec folder created with the supporting karma test to go along with it. So what we're going to do is let's look at this widget. We have a web app builder widget, as we normally see. We have it extending the widget base class, but we have it pulling in this Go to Dev Summit class. What this class is a standalone widget that does not rely on the web app builder. So we can see here in our web app builder widget itself, it's very bare bones. Pretty much in the post create, we create a new version of this widget and attach it to the widget's container is where we want it within the layout. Let's go see what this standalone widget looks like. In our widget file, we have a very simple widget here that is navigating to Palm Springs where the Dev Summit normally occurs. We can see in the HTML for that widget, which is what gets inserted into our Web App Builder widgets template, is just a simple little button that is telling us to go, and it's going to call that navigate to Dev Summit function. Let's go look at our tests that support this class. So as before, we have Karma, and so we have our go to Dev Summit. We have the coordinates for Palm Springs, and what we're going to do is we're going to have a spy for our scene view go to. Spying using the sign-on library is a method where we can wrap around these fake views and understand whether a method has been called without actually testing the code underneath it. So we're going to call our navigate to Dev Summit function, and we expect our spy to be called once and to be true. Then we're going to check our coordinates. We're going to expect that the call to the go-to is that of the coordinates of Palm Springs. So now we have a widget that could be used in other non-Web App Builder applications, as well as wrapped here to be used in a Web App Builder application with all of our testing available. As we conclude today, Jackie and I want to thank you for joining us and hope that you now have a better understanding of how to implement testing best practices into your JavaScript applications. Here's a lot of the resources that we used in today's presentation, whether it's from the CLIs or our legacy application, or the Web App Builder resources that you might be able to use to create widgets with testing. There's a great talk on unit testing, and one of our previous year's testing talks. We've used a number of toolings within our presentation today, including the intern and Karma as our test runners, Sign-on.js, TestMockito, and Jasmine. Sign-on.js gives us spies and mocks that we can use to use instead of building out full objects and testing other people's code, as well as TestMockito, which gives us strongly typed mocking as well. And then Jasmine is a popular test framework that allows us to create tests in a well-orchestrated way and clearly understand what each test is supposed to accomplish. So we thank you for joining us today, and we hope that you will be able to implement these practices into your own code.